Okay, so we're going to take a little aside here and talk about how to express values, constant values in Verilog. So just a little bit about Verilog syntax if you're not already familiar. If you are, you can skip this slide. So unlike software, where all of your values are kind of the same width, or maybe you've got 32 and 64-bit variants of values, in hardware you could have values that are represented by any number of bits. So generally when we're expressing values in Verilog, we'll explicitly say how many bits they are, and the notation for doing that is like this. So you start off with the number of bits in the value, and then a tick or a single quote, and then a character saying what format the value is. So either D for decimal, H for hexadecimal, or B for binary, and then the value itself. And there are a couple examples here. So there are a couple shortcuts you can take. If you just do tick 0, that's requesting that the compiler determine how many bits are needed for that value. There's also don't care values. So in most simulators, there is support for don't care values, which are neither 0 nor 1. The value is not known. And this can be useful in a lot of scenarios. The X will propagate through your logic if instead, if you really have a value that should not be utilized by your logic and it does end up propagating through your logic, and you can see that X downstream, it's an indication that you have an issue with your circuit. Alright, so just some examples of different values. If you just specify a value without any specific bit width, that's taken to be an integer value, which is a 32-bit value. And you can use that in your logic, as we have done already for the Fibonacci series and the counter circuit. All right, there are a couple, there can be differences between both synthesis tools and simulation tools. In the particular tools that we're going to use, and the configuration that we're going to put those tools into, we will allow the tool to extend values automatically by adding zeros or truncating as necessary to match the widths of the signals we're assigning. This won't produce any warnings, so be careful about that and realize that you could be inadvertently assigning the wrong number of bits and losing bits. Also, in our simulation environment within MakerChip, we're using a simulator called Verilator, which is an open source simulator that actually has a number of advantages over commercial simulators. But one disadvantage is that it only supports two-state simulations, so zeros and ones, no X's. All right, so ready for our next lab here. So we're going to do another example of sequential circuits. And this is going to be based on the calculator that you guys have already created. So presumably you've bookmarked your calculator or you still have it up. So go back to your calculator, and what we're going to do now is actually make this more like a real calculator. So in a real calculator, you enter the computation that you're going to do, you get a result that shows up on the screen, and then you say what you want to do to that value. You'll say +2. That's going to take the value that you had and add 2 to it. So we have to remember the value that we had. So we need a flip-flop. And this flip-flop represents a flip-flop of all the bits going into it. So this is 32 bits of individual flip-flops. So we're adding the memory essentially of the last value that we computed, and we're going to assume that we're computing a new value with every cycle of the clock. So for every cycle of the clock, we're saying add 2 or divide by 3, what have you. So the value that we had in the calculator previously is going to be the value that we're now providing as the first source operand. And then we're going to say to that value, you're going to subtract 3. So this is the way a traditional calculator works. And like always in our sequential circuit, we need a reset value. So just like the clear button on your old school calculator, we're going to reset the circuit to be holding on to a value of 0. Okay, so with that, I'm going to let you again pause the video and take your time to modify your calculator to introduce this state.